Welcome back to educator.com. For the next lesson, we're going to go over solving percent problems. Now, to solve a problem that involves percents, we want to first translate whatever the sentence is into an equation. Okay, so whenever you have a number, you're going to write that down in your equation. If you have a percent, you need to change it to a decimal. You see the word of, that means times. You're going to be multiplying. When you see the word what or what number, that means you're going to have a variable. So that's what you're going to be looking for. That's what you're going to be solving for. So this is almost the same as what we just did the last lesson. But now we're going to be looking at variables and solving equations. So we're going to have to do a little bit deeper into these problems. So the first set of examples, for example 1, 15. So remember, if we have a number, we're just going to write it straight down into our equation. Is. The word is, remember, it means equals 25%. Okay, so this, write down. This we're going to also write straight down, but because it's a percent, in our equation, we need to make it into a decimal. So percent to decimal, remember we have to move 2 decimal spaces to the left, because think of percent as a bigger version of a decimal, right? Decimals are small numbers. So whenever you're converting from a decimal or percent to a decimal, you have to get smaller. And the way for you to get smaller is to move the decimal point over to the left. So the decimal point is over on this side. Okay, if you don't see a decimal point, it's always at the end of the number. And then we're going to move it 1, 2 spaces. So the decimal point of 25% is going to be 0.25, and of course, obviously we have to drop the percent sign. Okay, so 25% is 0.25. So that's what I'm going to write in my equation. 0.25 of means times. So times what number? This is my variable x. Now be careful here, because whenever you write a dot for times, that looks like the decimal point, right? So the best way to represent multiplying is to either write it in parentheses. If you're going to show that you're going to be multiplying 2 numbers, write them in parentheses. Or if it's a number with a variable, a letter, then you can just put them together. Okay, so 0.25 x. That would mean 0.25 times x. Okay, so here's our equation now. This is what I'm solving for, right? 15 is 25% of what number? So this is the number that I'm looking for. Now, when I solve for x, remember that since this is 0.25 times x, I need to do the inverse operation. Okay, so 0.25 times x, the inverse operation is divide. So in order to solve for x, I have to divide 0.25. Okay, 0.25 over itself is going to be 1. Whatever I do to one side, I have to do to the other side of the equal sign. So then I have to divide this side also by 0.25. And this, it looks like a fraction, but fractions are division problems. So this is the same thing as 15 divided by 0.25. Another way to explain why we have to divide, let's say I have 8 equals 4x. So if I have 4 times a number equals 8, well, what do I know about x? Isn't 4 times 2 8? So I know x has to be 2, right? So in the same way, if I have to solve for x, and I can just divide this number by this number. So divide this by 4, divide this by 4, then 8 divided by 4 is 2. And that gives me 2 equals x. Okay? So here, 15 divided by 0.25, I need to actually solve that out in order to find x. Okay, so let's review over how to divide numbers with decimals. If I'm going to divide these two numbers, remember that the top number is what goes inside that when you divide. So 15 on the inside, 0.25 on the outside. The decimal point for this number is at the end because we don't see one, right? So it always at the end. Now, whenever, if I need to add zeros to this number, I can, because I can always add zeros to the end of a number behind a decimal. If it was before the decimal, I can't, because then that'll just become 150 instead of 15, right? So as long as it's behind the decimal and it's at the end of a number, you can add as many zeros as you want. So I can add 2 zeros, I can add 3, I can add 10, okay, however many I need. This number, we want to change to a whole number. So I need to move the decimal point over 2 spaces to the right, okay, to make the decimal point at the end, right? So if I move 2 decimal places for this number, then I have to move this 2 decimal places over here. Then I'm going to take that decimal point up. 25 goes into 15, 0 times. 25 goes into 150, how many times? Well, think about quarters. 25 cents or 25 is like a quarter, right? So how many of those fit into 100 or a dollar? 4 quarters of a dollar. So think of 150 cents. 25 cents goes into 150 cents or $1.50. How many of them? So that'll be 6. And if you want to just check that, this is 12, 14, 15, right? Okay, so then that becomes 0 when you subtract it. Then I can bring down this 0. 25 goes into 0 times. Okay, I have to fill in this space right here. So then that's 0. Subtract it, that's nothing. I don't have to bring down another 0 because my remainder is 0. So then my answer then, if I do 15 divided by 0.25, is this number up here, 60. Now this number, if there's a 0 in front of the number, like that, then that doesn't mean anything either, right? I can just drop the 0. So it would just be 60. Now this 0 I cannot drop, right? This 0 has to stay there, because if I drop it, then my number is going to change to 6. And we know that 6 is not the same as 60, right? So this 0, it's not after the decimal point, so we can't drop that 0. So my answer just becomes 60. Okay? So if you need to review over this, you can either go back to that lesson, dividing decimals, or we're going to do a few more problems that involve dividing decimals. Okay. So the next one, again, we're going to change this into an equation. 1 is equals 4%. Okay, 4%, again, we have to change it to a decimal, right? Now be careful, 4% is not 0.4, because if I, again, 4%, okay, to decimal, the decimal point is at the end right here. I go 1, 2, and then put the decimal point there. I have an empty space that I have to fill. Well, I have to fill that with a 0. So it's going to be 0.04. Okay, again, at the end here, 1, 2, decimal point. So 0.04. Of means times and blank. That's what we're looking for, right? So that's my variable. I'm going to put x there. So remember, if I put number with variable, that means times, right? So then this represents, I don't have to put a dot here. I don't have to use parentheses when it's number with variable. So again, how do I solve for x? Look at this example again. Okay, if we're going to do 8 equals 4 times a number, okay, I can take this number, divide it by this number, right? 8 over 4, and that's going to give me x. So then I have to do this number, divide it by this number. So remember that this over this becomes 1. So this whole side, my right side, just becomes 1x. 1x is the same thing as x. Now, that's probably a little bit hard to understand, 1x being the same as x. But it's like me saying, I have an apple. If I say I have an apple, you know that I have only one apple, right? Even though I didn't say I have one apple, you just know. Because how many A's do you see? Well, you see 1, right? So an A is the same thing as 1A. Okay, an apple is the same thing as 1 apple. So just think of that as having 1x. Okay? And then again, we have to divide that. So 1, be careful, the top number is going to go inside. And then 0.04, the bottom number is going to go on the outside. Again, I have to move this decimal point over 1, 2 spaces to the right. That means I have to take this decimal point. It's at the end, right? Go 1, 2 spaces. I have to fill these in with zeros. There's my new spot for my decimal point. I bring it up. Okay. Then 4 goes into 10 how many times? 4 times 2 is 8. 4 times 3 is 12. 12 is too big, so then it only fits into 10 twice. So 2 times 4 is 8. Subtract it, I get 2. I'm going to bring down this 0. 4 goes into 20. How many times? 5 times. 4 times 5 is 20. Subtract it, I get a remainder of 0. So I can stop there. My answer becomes 25. And I don't have to put that decimal, right? Because it's a whole number and it's at the end. So my answer, x, is 25. So right here, this is 25. And again, 1x is the same thing as x. So what did this become? This became 25. So if 25 is x, then I can just say that x is 25, right? It's the same exact thing. The next one, 20 equals 100% to decimal. Again, start at the end, and you're going to go 1, 2, right there. It's going to be after the 1, 1.0. Remember, if the zeros are at the end of a number behind the decimal point, then I can just drop it. So isn't this the same thing as 1? So I can just write 1. 100% as a decimal is 1. Okay? Times, means times what number? That's my variable. So 1 times x. Okay, so 20 equals 1x. Remember, 1x is the same thing as x. Because if I have one apple, that's the same thing as just saying I have an apple. If you want, you can go ahead and divide the 1, just like we did the other problems. 20 divided by 1 is 20. Whenever you have a number divided by 1, it's always itself. So 20 equals x. Or I can flip this around. If 20 equals x, then isn't that the same thing as x being 20? So either way, that's correct. Okay, we just want to know what the number is. The number is 20. Or you can say 20 is the number. Okay, it's the same exact thing. Let's do a few more examples. These are a little bit different. What percent of 50 is 10? So now the variable, what we're solving for is the percent. So be careful here. So what percent? I'm going to make that x times 50. 50 is equals 10. Okay? So x times 50 equals 10. Now, remember, you can change this if you want to 50x, right? Just like we did the other problems, because a number times a variable is just, you just put it together with a number in front. So 50x equals 10. It's the same thing. Now, how do we solve for x then? How do we get what x is? Well, remember my example? Let's say I have 3 times x equals 6. You can do this in your head and know that 3 times 2 equals 6, right? Well, another way for you to solve it is to do 6 divided by this number, right? This divided by this. So, same thing, we can just do 10 divided by 50. It's not 50 divided by 10, okay? It's this number divided by this number, the one that's multiplied to the variable. So, I can show you this way. So, 50 over 50, that's 1. 10 over 50, that's what you have to do, right? 10 divided by 50. Okay, again, fractions are the same thing as division. So, 10 divided by 50. Now, a shortcut way of doing this is if you're dividing two numbers with zeros at the end of it, you can just cross out the 0, okay? So if there's 1 0 up here, 1 0 down here, you can just cross out 1 0 from each of the numbers, as long as there's zeros in both numbers. Okay, but we're just going to go ahead and just divide it this way. Okay, so 50 divided by 10. Now, it's not going to go into this number, right? This number is too big to go into this number. So I'm going to have to use my decimal point. Do I move it at all? No, because there's no decimal point here, right? So I can just bring it up. Bring it straight up. I can add zeros at the end, behind the decimal, at the end of a number. So now I can just look at this, 100, 100. 50 goes into 100. 50 plus 50 is 100, right? Or 50 times 2 is 100. Okay, think of 50 cents. 50 cents goes into 100 cents how many times? So, and 100 cents is the same thing as a dollar, right? So 50 cents goes into a dollar twice. This becomes that. You subtract it, you get 0, no remainder. So that's my answer. I don't have to bring down any more zeros because my remainder became 0. So when I divided this, my answer became 0.2. X equals 0.2. Here's the thing though. They're asking for percent. So even though this is my answer as a decimal. They want it in percent. They're asking what percent. They're not asking what decimal, right? So what percent? I have to change this number to a percent. So decimal to percent. Remember, decimal is a small number. Percents are larger. So I have to go from a small to a larger. That means I have to move the decimal point over 2 spaces, but which way? If I go to the left, I'm going to get smaller. But if I go to the right, then I start getting whole numbers, right? So I make the number bigger. So 0.2, to make it into percent, I need to make it bigger, so I need to go to the right. 1, 2. I have to fill this space with something. So 0.2 as a percent will be 2, 0, and then percent. Okay, the decimal point is right here. It's at the end. If it's at the end, remember, you could just, it doesn't have to be there, right? You can make it invisible. And then we have to write the percent sign because we changed it to a percent. So my answer is then 20%. That's That's my answer. So 20% of 50 is 10. Another one, so again, what percent, make that x your variable, times 75 is equals 7.5. Again, we have to do this number divided by this number. So 7.5 divided by 75. And again, if you want to see it, I can show you this way. Okay, because this you have to get rid of. Okay, by dividing it. Okay, this 75 over 75 is 1. So 7 times, or x times 1 is just x, right? X equals, and then I have to actually divide that to find the answer. So here I don't have to move the decimal point anywhere because it's at the end. So then this decimal point will just come straight up. 75 goes into 75 how many times? Once, right? 1 times 75 is 75. Subtract it, I get 0. So then I don't have to go any further. 0.1 is my answer. So x equals 0.1. But again, remember it's asking for percent, so be careful that you don't forget to change it to a percent. So I am going to put that here to represent decimal. Change it to percent. I'm going to go 1, 2 per point. So 1, fill the space with a 0. Okay, put the percent sign. So 0.1 in decimal becomes 10%. So x equals 10%. There's my answer. And the last one for this, again, what percent x times, of is times, 4 equals 4. Well, this one we can just do in our head, right? What times 4 equals 4? Isn't this 1? 1 times 4 equals 4. Okay, 4 times 1 it equals itself. So then I don't have to solve this. I can just make x equal to 1. So if the problem is fairly easy, you can just do it in your head, then go ahead. There's no need for you to do all the work. Unless your teacher wants you to show the work, right? Okay, so then x equals 1. Now, since x equals 1, oh, I didn't mean to box this. Okay, that's not my final answer, so I don't want to box it. Now, since x equals 1, I need to change it to percent. So, how do you change a 1, a whole number, into a percent? So, again, where's the decimal point? I don't see it, so if I don't see it, it's invisible. It's at the end, like that. So, go 1, 2, point here, so then I have 2 spaces to fill. This becomes 100%. So this x equals 100%. Okay. The next example, we're just going to do a few more, just different types though. Okay, so the other examples, they were the same kind, all the problems on that page. 15 equals what percent x times 150. So let me rewrite this equation out. Since this is 150 times x, let me just write it here. So 15 equals, remember whenever I do a variable times a number, I want to write it together, but with a number in front. So 150x, like that. And then to solve for x, remember I have to do this number divided by this number. So I'm going to divide this side by 150. Whatever I do to one side, I have to do to the other side. Okay, that way this becomes 1x, or 1 times x, 1x. And that's the same thing as x, right? So 15 divided by 150 divided by 150. No decimal point here, so I don't have to move it. So instead, I need to draw that in, bring it up, add zeros. 150 goes into, well, 15. We know it doesn't go to 15. So if you want, you could put a 0 up here. If not, then that's fine. Just remember that it's now the next 3, okay? Or just these 3. 150 goes into 150 one time. So that becomes 150. If you subtract it, it becomes 0. Okay. I drew an extra 0 there, but you don't even have to bring it down because it's just going to be zeros. And then remember, zeros at the end of a number behind the decimal point means nothing. So 0.1 is my answer. So x is going to equal 0.1. You can also say 0.1 is going to equal 1x or x, same thing, right? But I can switch it like this. And then it's asking for percent. So I need to take this point, decimal point, and go 1, 2. Fill in the space. It's going to be 10%. So 0.1 is the same thing as 10%. Okay, the next one. 30%. Now, this is written out as percent, but it still means the same thing as percent like that. So 30%, I have to change that to a decimal. So 30% becomes, at the end, you go 1, 2, right there. So 0.30 or 0.3. Remember, it's zeros at the end, behind the decimal. It doesn't mean anything. 0.3 or 0.30 of times 12. Now it's number times number, so I can't write it next to each other like how I do numbers with letters, right? I have to put it in parentheses. Is equals what number? Okay, this is my variable. So all I have to do to figure out what x is multiply those two numbers, right? So then 0.30. You know what? We know that the 0 means nothing, right? So let's just make it easier and just not even have that 0. So that way a single one-digit number is easier to multiply, right? Okay, so I'm going to put the 12 on the top, 0.3 on the bottom, multiply it. 2 times 3 is 6. 3 times 1 is 3. From here, I only have one number behind a decimal point, so then start at the end and go place the decimal in there. Okay, so then what I just did, when you multiply decimals, you have to count, this decimal point is at the end, right? Right here. So you count to see how many numbers are behind the decimal point. Here, I only have 1. So then I start at the end and I only go 1 inwards, and then that's where the decimal place goes. So x is 3.6. So to finish this equation, 3.6 equals x. So 3.6 is the number, or I can say the number is 3.6. The next one, 5%, change that to a decimal. Start here, go 1, 2. So it's point, fill in that space, so it's 0.05. It's not 0.5, 0.05. 0.05 times my unknown, which is x. So x equals 4. Again, I have to solve for x, which means I have to divide 4 divided by 0.05. 4 divided by 0.05. I have a decimal point here, so I have to move it. 1, 2. There's my decimal point. I'm going to move it. 1, 2. Bring it up. Fill in these spaces, zeros. Okay, 5 goes into 4, no, 0 times. 5 goes into 40. So 5 times, we know 8 is 40. So, all right, 40 down here, subtract it, 0. Okay, I'm not finished with the number yet, so I have to still, because I still have space up here, right? So bring down the 0. 5 goes into 0, 0 times. That's why for this I have to keep going. Even though this became a 0, I have to bring down the 0 and solve it again because there was an empty space before my decimal point. In that case, you have to continue. If it's after the 0, like in this problem right here, if it's after the decimal point, then I can stop once I get 0 as my remainder, right? But for this, if there's a space here before the decimal point, then I have to go again until I fill in those spaces. So here, this is 80. X is 80. And they're not asking for a percent. So 5% of 80 is 4. And the last one, 100% of 3,448 is what number? They're asking for 100% of this number. 100% is all of it, is the whole thing. So 100% of this number is just this number. If you want to solve it out, how we solved out the rest of them, 100% as a decimal. Again, move the decimal point over 2 spaces. That becomes 1 or 1.0, which is the same thing as 1, times. So times 3,448. So I'm going to change this to parentheses. 3,448 equals what number? X. Well, 1 times this number is just that number, right? So I can say 3,448 is the number. Or the number is 3,448. Okay, so that's it for this lesson. Thank you for watching educator.com.